Hello everyone, I'm going to present my capstone project of advanced data science. The project which I selected is image classification. In this project, I'm going to classify the numbers from the dataset NIST by two methods. One is by using PyTorch and another by Keras. Okay, so this data set that I choose is a standard one to do this kind of uh, analysis by using neural networks. I will choose this data set that contains 60,000 training image and 10,000 testing image. So I will try to perform this analysis by using convolution neural networks in PyTorch and also in Keras, and later we will do the comparison between both models. Just let me give you briefly the results, and later I will show you the, the notebook that I used. The first result is given by the PyTorch, where in PyTorch we train the neural networks by using convolutional neural networks, and we got this behavior with this accuracy that it's around 0.9075 with at around 4 epochs, and with instead of now, if we perform the same analysis but now without a convolutional network, we obtain a bit better accuracy with Keras. And again, if we perform the same calculation but now using convolutional networks with Keras, we obtain a much better result, that is 0.98%, but there is a bigger error. So we have noticed that the method by using the PyTorch library requires more computing power than in Keras, and therefore if we increase the dataset for the convolution procedure, should be a problem. So in this sense, for bigger data sets, we suggest use Keras without convolution, and which gives an acceptable accuracy values. And and PyTorch use more power computing and have less accuracy. Okay, so let's check now the procedure, how we perform that. So the first the structure of this notebook has two parts. The first part, we introduce the PyTorch scheme. First, we import the basic libraries from PyTorch. If we don't have installed in my Jupyter notebook, I am using Anaconda. We can use this command and install the libraries. We define the function for the plotting channels, and And also we define the function for the plotting of the parameters, the plot definition of the plot activation. We don't use this one, but just we use if we want to do that something with this. And we show the data. No? Here we introduce the data. We create a transform to resize the image and convert it a tensor. And we load the data. This is the command to obtain the data by the library of the PyTorch. That is already a dataset that is given in this library. And here we obtain the validation dataset. One is the train dataset, and the other to check. As an example, if we want to see the picture of one of the elements of the dataset train, so this is an example for the second element. This is 1, 0, but this can be another one. I don't know. As an example, the number 0 is 5. The second element is this one, and so on. No, this is just as an example, but now we remain with the same that we were doing with the second. The convolution network. Okay, we built a convolution network class with 2 layers and one fully connected layer. The parameters in the constructor are the number of output channels for the first and second layer. This is the constructor, this is the predictor. We use torch and those here are the outputs. We have for the forward and for the activation. Okay, so we choose 16 output channels for the first layer and 32 output channels for the second layer. And we define the loss function, the optimizer, and the dataset loader. The learning rate that we choose is this one. The criteria for define the loss. In this case, we use the NN cross entropy loss. We can use other types. Usually, when we have this kind of classification of numbers, or especially for classes that are not many classes, this criteria is one of the best. We can check the helper manual for the PyTorch, and they suggest use this one for this kind of classification for especially this dataset. We use this batch size, okay, and for the validation we increase the batch. And here, in order to make the comparison with other model that using Keras, I will use 10 epochs, and here we just create the cost and the accuracy list in order to do the plot. We perform this training part, and after we got the training, we got this. That is the loss and the accuracy by epoch. That is close to 0.97 with 4 epochs. Now, if we repeat the same procedure, but now instead of use PyTorch, we use Keras. And again, now we import Keras dataset. We import NIST, In Keras also you have the data set of NIST. Just let me do a comment. In PyTorch, the data element are tensors in form of tuples. Here as an example, here is the train data set as an element, and in Keras we have arrays like in this one. Okay, so fortunately in both libraries we have the data sets. We can set or create a custom data sets for PyTorch or for Keras, but now for this capstone, let's choose the NIST in order to show how it works. So with the conventional neural networks, we use this one. First, we find the one-dimensional vector, later on the flat training images, flattened images test. Here we normalize to 255 because the colors, I mean, because the images are in the range of 255 colors. So in order to have a normalization, we just make this division between the train and the test. It's only a normalization. Later we have to do the one-hot encode in order to have only 0 or 1 categorical. And later we do the classification model. The classification model that we use in this case, we use the activation ReLU, and later we use the softmax. The optimizer that we choose is the Adam. We use the cross entropy. We use accuracy. Now we built the neural network. I define history net in order to save the information of the training part, and here we save the results in the evaluate in the scores value, and we perform this training, and after the training we got this accuracy with this error. Now if we want to plot the results, we obtain this is the accuracy with the test, and if we repeat the same, but now to show the loss and the box, this is the behavior without convolutional neural networks. Now if we introduce the convolutional neural networks, pooling and the convolution layers, in Keras is easy. We only have to import those two libraries, and later when we include those libraries we repeat the same procedure. We have the train and the test, we do the same normalization, and we do again to the binary categories, and later we do the definition of the model. We create the model, we use again the activation ReLU and softmax with Adam, with cross entropy, okay, and here this is the difference with the convolutional layers. Here we use the convolutional 2D max pooling. Here we repeat the same strategy. We do the model this deconvolution model that I presented before, and now I call this